What's poppin'? Oh shit, that's me, I'm mopping. I got options. Need a new test tube, I'm shopping. You still watching? Ask me when the mixtape dropping. It's not. Yeah, it might be shocking, scientists, but I get the whole club rocking. In the lab, please don't come knocking. Running experiments just like I'm jogging. I publish a paper and say see you later and hop on a jet to a conference. These videos full of some nonsense. The misinformation's obnoxious. How you post that with the conscience? I tear them up in my responses. Lately I started to notice these profiles giving off fishy aromas. Sometimes I feel like I might just be fighting the Russians like Rocky Balboa. You should read some of my comments. Apparently Google is doing diplomas. They tell me to do my own research. I'll show them t-tests and two-way ANOVAs. Stay on my business. You come at me, I fire back with statistics. I got all the specifics. I just fight for the truth and I make it my mission. So just sit back and listen, cause I'm telling y'all this is a dangerous place. And they got it written all over their face. So get on my team and let's start the resistance.
Take it away, Ben.
Good morning, everyone. You know, if 2 years ago you told me that I'd be introduced on stage for a scientific presentation with a video of me rapping, I probably would have asked, what the hell went wrong? But despite what you just saw, I am in fact a scientist. I'm a neuroscientist, postdoctoral researcher in the lab of Dr. Robert Malenka at Stanford University. And before I get into my talk, which is going to be about the neural basis of empathy and how MDMA enhances empathy, I want to start by just explaining where I come from and my origins in neuroscience. I was a student of psychology until one morning I woke from a tremendously frightening nightmare. And I just couldn't help but be amazed by how alarming and vivid and intense the experience was. And I think I came away from that with a feeling that many people experience coming out of a psychedelic experience, which is, I can't believe that I'm capable of experiencing something like that. And that's where my interest in the brain really developed. And so from there, I ended up doing my Ph.D. in neuroscience, and I learned that I was really interested in social interactions. And I think that it's very interesting that if you take a look around any hall or cafeteria, anything, a mall full of people, you will see a natural spectrum of sociability. Some people are grouped in large clusters and there's one person entertaining the whole bunch. Sometimes there's people sitting off in the corner reading a book on their phone. And these people are all comfortable in whatever they've found, their level of sociability. And it's just interesting to me that those natural differences that we encounter every single day must represent differences in brain function. And so I got lucky that I was able to study this phenomenon, study sociability in my PhD, where I studied autism spectrum disorder, and specifically how genetic mutations that are associated with autism change brain function, specifically looking at synaptic function. But I've learned over time that I was more broadly interested in not just autism, while it is important research, but the neural mechanisms underlying things like empathy and just these interactions, these components of interactions that we experience every day. So I moved on to Stanford to work with Dr. Robert Malenka, and if we have any neuroscientists in the room, you might know Rob. Rob is a world-renowned neuroscientist. He's known for characterizing much of what we understand about synaptic plasticity, which is the ability for synapses to change with experience, the very process that psychedelics act upon indirectly. But like me, Rob shares an interest in understanding how the brain works and how the brain regulates social interactions. And in recent years, beyond synapses, Rob's lab has moved to study circuits. And in even more recent years, they begin to study MDMA and other substances like MDMA and psilocybin, psychedelics, to use them as sort of a probe to understand what are the natural systems in the brain that these drugs are acting upon. So MDMA is a very unique drug in that it induces such a robust and profound connection between two people in many ways. It's increased extroversion, emotional warmth, social connection, empathy toward others. And the way Rob and I look at this is that if we can administer MDMA to a person and they become much more social, this sort of opens this vast window that we can start to look at what systems are being activated by MDMA, and through that we can start to understand what are the natural systems that exist already in the brain that can be acted upon to enhance something like empathy toward others. So I'm going to break my talk down into three primary sections. And the first is just going to go over the phenomenon of empathy and what it exactly is. I think everyone here probably has some sense of what empathy is. But I want to start by taking you through the experience of empathy. If you see this image, you might feel empathy. I think walking by this person on the street, you would probably feel more empathy. But you start to get an idea. I mean, who here, I'm actually curious, who here is feeling a sense of empathy looking at this image? Okay. In this last week, if anyone follows American football, there was a player suffered cardiac arrest on the field. I'm from Buffalo, this is my team. And the players were distraught. I mean, he was administered CPR on the field for 10 minutes. And you could see these players experiencing empathy for their teammate. You might even experience empathy just looking at this person. This guy, he's not the person that got injured. He's watching the person that got injured, and you might feel empathy for him. If you're really empathic, you might feel empathy when you're driving on the road and you see someone on the side fixing a tire, they got in a car accident or something. Of course, beyond the human realm, many of us feel empathy for animals. I think this is heartbreaking to see for many people. And in fact, research even suggests that we can feel empathy for emojis. I'm not kidding. Really interesting paper, actually. They showed that there's a brain response in EEG when you look at a human face in pain, and there's a very similar response looking at something like this, an emoji in pain. So we've gotten a sense of what it feels like to experience empathy, but now in a scientific way, we need to define empathy. And the scientist Franz de Waal defined it neatly in 2017. It's the sharing of emotions between individuals and the adopting of another's point of view. And so empathy really starts at identifying another's emotional or physical state. So in those last images, you saw a person, for example, the homeless man over here, you saw this person and you identified this is a person in distress. Then you might relate or step into the experience. And that kind of happens in two steps. There's an initial emotional response that is almost unconscious. You see something and you immediately feel something. And what you're really feeling is a sense of what that person's distress might be like. But then if you really want to, you can step into the experience and through cognitive empathy, you can decide to take part in that experience and see how would I feel? You can put yourself there. Sometimes this relating experience might even involve the adoption of that state. So personally, maybe we all have people in our lives that we care about so much. For me, it's my mother. Every time I see her cry, I immediately start crying. It's involuntary. I don't know why, but I suppose this is why. Because you see someone you care about experiencing a deep emotion, you mirror that emotion. So to me, my definition of empathy stops here. It is the ability to observe, identify another person's state, and then relate to it, step into it. But in many cases, empathy can elicit a helping response. And this is sort of now entering the realm of compassion and caring, which is different. It's related, of course. But the way I look at it is that empathy is critical for social interaction. And that process I described of where you immediately start to feel bad when you see someone else in pain or in distress, that's so valuable for social information transfer because you don't have to think about, should I help this person? It's automatic, and through that, it allows information to pass quickly within groups. So speaking of this experience, sorry, I apologize actually, but this is important because I want to know now who in this room feels uncomfortable. All right, I've successfully made the entire room uncomfortable. The reason I show you this is because empathy for pain is a very valuable and really thoroughly studied phenomenon in neuroscience. In fact, this is a meta-analysis. In David's talk, he talked about meta-analysis being at the top of, this is a meta-analysis of several studies looking at brain activity in basically people who are sitting looking at images of someone experiencing pain. And in many cases, this isn't the exact image they use. It's a person being poked with a needle or something like that. I thought this was less graphic. Maybe I'm wrong. But they looked at people's brain activity, and they found that consistently across multiple studies, there are certain brain areas that are routinely activated by observing someone else's pain. Those are shown here in green. And you can see that there's actually a pretty good amount of activity throughout the brain, but we're looking at areas like the insular cortex, the cingulate cortex. But as I mentioned, observing someone else's pain is painful, and as you all just experienced. And what's really, really fascinating is that what you see here in red, those are brain areas that are activated not only by observing someone else's pain, but by feeling pain itself. And you can see that there's some overlap in the areas that I just mentioned, the cingulate cortex, the anterior insula. It's quite interesting. And it suggests that, to some degree, observing another person's pain is painful for you. There are many factors that modulate empathy. Everything on this slide, except where I note, has been shown to not just increase or decrease levels of empathy that you feel for someone, but actually the level of activity in those empathy-related brain areas, the anterior cingulate cortex and the insula. So, of course, the intensity of the experience and the level of emotion, you're going to feel more empathy for someone that's being hit by a car than someone, tripping and stumbling. If it's more extreme, you're going to feel worse for them. The observer's personal experience and history. So those of you who have had their hand slammed in a car door before probably felt more empathy, probably felt more distressed by that picture. But what's really interesting is the ability to relate physiologically. So if any of you in the crowd had taken something like Tylenol this morning, there's a chance, research suggests that you would be less likely to feel discomfort from that image. So by actually preventing the brain systems in you that are experiencing pain, or by toning those down, we can actually reduce the amount of empathy you feel for someone else's pain. And those born with insensitivity to pain also feel much less empathy for others' pain. The context of the experience, so if you're showing someone being pricked with needles and you think, ooh, no thanks, gross, but you find out that they're actually getting acupuncture, it's a therapeutic process, they're going to benefit from it, you're likely to feel less pain or less empathy. Familiarity and the strength of relationship, like I said, my mother is someone I'm very close with, you feel more empathy for those who you are close with. In-group versus out-group, and this can be racial identity, group allegiance, religion. Studies show that there's less activity in these brain areas when viewing, even if just a hand labeled with a word, Jewish. If you're not Jewish, you feel less empathy. If you are Jewish, you feel more empathy for that hand being pricked with a needle. It's really interesting. There's just these natural processes by which we care more for people who are like us. And then fairness and likability of the demonstrator. In this really cool study, they put people through this process where they were given the opportunity to send money to another player. That player was an actor, and that player could either choose to send all of it back or none of it back. And they had two actors. One sent back low amounts of money, one sent back large amounts of money. So they had a fair and an unfair player. And then they electrified their hands in front of the person. And people felt less empathy for and had less brain activation in empathy regions for those who played unfairly. So be nice, people will care more about you. And now, of course, as I mentioned at the beginning, substances like MDMA, although, MDMA on this list is the only one that hasn't been explicitly shown to increase those areas in this specific phenomenon of observing someone else's pain. So that there's a gap there, and we want to address that. And so that's what my research has been doing. So the question that I'm really answering in my studies is, how does MDMA enhance empathy? And you may be upset to learn that the research I'm going to present is actually in mice. And of course there are many, it can be controversial doing research in mice. I'm not naive to that. But through mouse experiments, we can really do much more detailed, thorough, we can ask much more detailed questions. We can get down to not just the level of, is a brain area more activated, but we can say, if this brain area is more activated, where are the inputs coming from? What other brain areas are communicating with that brain area? What neurotransmitters are they releasing? What receptors are those binding to? And how is empathy really occurring? And we can actually study this during the MDMA experience, which is something that's very challenging to do in humans. And so maybe you're wondering, can mice even experience empathy? How do you model empathy in mice? And so there's this paper that Rob's lab published with Monique Smith as the lead author. She just started a lab at San Diego, where they showed something called the social transfer of pain in mice, which is really interesting. And it's very similar to kind of what you experience when you see the picture of someone being hurt and you start to feel, ooh, discomfort. So if you have a mouse that's been injected, there's a compound called CFA. It induces like an inflammatory response. You can think about it like arthritic-like pain. And it's just in a single paw. And if you expose that mouse, so first you can test the pain level in that mouse with something called von Frey mechanical testing. Very simple. So if you think about like a toothbrush bristle, right? It's not, if you poke yourself with it, it's not painful. But if let's say you were walking around all day and you had a blister on your toe and you poked yourself with a toothbrush, you might withdraw, you might say, ooh, that's uncomfortable. That's essentially what we're doing here. And you can see that compared to control mice, and this is a very basic thing that's been replicated many times in science, the CFA injected mice have much lower mechanical thresholds, meaning they're much more sensitive. So they respond to a much lighter poke. But what's really interesting is that when you expose a bystander mouse that's healthy, never experienced any pain, for 1 hour to the mouse that's experiencing this sort of arthritis pain, the bystander mouse also shows this pain-like response, which is really interesting. And so they called it the social transfer of pain. And I hope you will join me in believing, at least for the next few slides, that this can be a model of empathy because it's an animal observing another's experience and sort of adopting that same state. And so the question becomes, of course, why I'm here, if we give the bystander mouse MDMA, does it enhance this social transfer? Do they take on more of the other animal's pain? So I want you to get used to seeing graphs like this right here because you're going to see a few of them. So first we're looking at the CFA mouse in navy. I hope I'm colorblind. I did make these graphs, but I never checked what colors they are. And so you can see at the pre-test, they're up here, and then after the injection, they go down, but they become much more sensitive, and they remain more sensitive for about 48 hours. So if we give this mouse saline, control, placebo if you will, and you have them interact for just 10 minutes. So previously the graph I showed you was for 1 hour. Just a 10-minute interaction, they don't show much of an effect. They come down a little bit, they become more sensitive about 1 hour, and then they retreat back to baseline. But if we do the same interaction where this mouse is given MDMA, we see a much more severe response. Not only are they more sensitive at 1 hour, but while these saline-treated mice retreat back to baseline by 6 hours, 24 hours, the phenomenon is strengthening in the MDMA mice, which is really interesting. And it suggests, as we hypothesized, that MDMA is enabling the mice to take on more of the other's pain. And you might be thinking, well, what if it's just the MDMA? We are scientists, we controlled for that. If you give the mouse MDMA, but you have them interact with a healthy mouse, they kind of just hover around baseline, they bounce around. So I'm not presenting this just because it's, yes, we found out MDMA is empathogenic in mice, and mice behavior is cool. No, this is just a model for us to now use to interrogate the brain circuits that are regulating the phenomenon. And so a hint of where we might begin our study comes from the nucleus accumbens. So this is a brain area that's present both in humans and in mice. And it's part of the reward system, and it's very much involved in motivating behavior. And it's especially involved in motivating social behavior. And so a previous study from our lab, led by Boris Heifetz, who's also, some of you may know, he's in the psychedelic space, now leads a lab at Stanford. They found that if they put MDMA directly into the nucleus accumbens, so bypassing the entire rest of the body, just in the nucleus accumbens in mice, it made them more social. It made them interact with other mice more over the course of a 30-minute window. And so this suggests that maybe MDMA's activity in the nucleus accumbens is driving these pro-social effects, and perhaps it's driving empathy as well. So that was the next experiment we did. We infused MDMA through a cannula into the nucleus accumbens. And the result is that, of course, our CFA mice, again, show the same effect. If you put saline through the cannula, those mice, after a 10-minute interaction, show mild response, same as the other graph. But the MDMA mice show a very pronounced response, where actually at the 1 hour time point, they're essentially overlapping. They're just as sensitive as the mice who actually receive the CFA injection. MDMA mice are looking just the same, and then they retreat back to baseline. So this suggests that whatever MDMA is doing, it's at least partially doing it in the nucleus accumbens. So what is MDMA doing? Well, what does MDMA do? MDMA, let me step back. Quick basic introduction. In the brain, we have about 86 billion neurons or so. That number will probably change as we learn more. But our brain cells interact at these little junctions called synapses. And so what MDMA naturally does throughout the brain is it drives release. So from the presynaptic terminal, the neurotransmitters are carried in these vesicles, and MDMA, when it's taken in the body, it causes those vesicles to just start releasing. It increases their release. And there's 3 neurotransmitters that are specifically enhanced. It's serotonin, dopamine, and norepinephrine. And of course, many people know oxytocin, things like that. These are the primary neurotransmitters that are acted upon by MDMA. Many things occur downstream of that. But this is nice because it allows us to say, okay, whatever we're experiencing or whatever we're finding, it's probably due to one of these 3. If it's due to something downstream, well, by manipulating one of these 3, we can still find a change that, if the downstream mechanism is still altered through that one of these neurotransmitters. So it now becomes a kind of a game of Clue. It's like, where do we go? Which of these should we choose? And of the 3, I decided to select serotonin for my future studies because serotonin has been shown also in the nucleus accumbens to be prosocial, and that it drives social behavior. So could serotonin activity driven by MDMA be enhancing empathy? Well, the next experiment that we chose to do was to take MDMA out of it. And so in the last experiment, I put MDMA right into the nucleus accumbens. Here we're saying, okay, let's take MDMA out. Let's just cause a bunch of serotonin release in the nucleus accumbens. And by doing so, we're essentially inducing the same effect, but we're leaving dopamine and norepinephrine out of it. And so we used a technique called optogenetics, where we can actually It's very complicated. If you'd like in the Q&A, I'm happy to discuss more, but you can shine a laser on these brain cells and they activate, and it causes local serotonin release just in the nucleus accumbens. And so when we do this, what we find is that our control mice, once again, show little effect, but just release of serotonin in the nucleus accumbens produces a very similar effect to what we saw with MDMA. And mouse behavior is naturally variable. You can see that there's some variability. There are error bars and stuff, but actually it's pretty incredible. If you overlay this result right here, the serotonin, with what I showed in the previous graph, they're almost entirely overlapping, which is extremely rare. I had to go back and make sure I didn't mess up my graphs. So this suggests that the effect we're seeing from MDMA is likely driven by serotonin. So to summarize what I've shown, MDMA does enhance empathy even in mice. Putting MDMA just into the nucleus accumbens is sufficient to enhance empathy. And then just releasing serotonin alone in the nucleus accumbens can enhance empathy. So I'm sure many of you are wondering, like, okay, well, what does this mean? What's going on? Well, my prediction here, and by the way, I forgot to mention, should have said this much earlier, many of these slides contained do not photograph. This is all unpublished work, so I should have said to not take pictures. If you did take pictures, I just asked that you not publish on social media or something like that. So this is all unpublished, and so this is why I have a prediction and not a conclusion. But my prediction is that serotonin release is modulating the signals from those empathy brain regions. So I showed you that those areas like the anterior cingulate cortex and the insula are activated by empathy. Well, what I think is happening is that when you observe someone in pain, the anterior cingulate cortex, and these are just very roughly drawn on in PowerPoint, so these aren't exactly where these brain areas lie, but the anterior cingulate cortex sends signals to the nucleus accumbens to signal empathy. And this has already been shown, actually, so this is a known thing. But what I believe is happening is that the dorsal raphe nucleus, the largest serotonin hub in the brain, is sending serotonin to the nucleus accumbens, not to act necessarily on the brain cells in the nucleus accumbens, but to modulate the activity of these inputs. And so I think that when the serotonin is released, these sort of get hot. They start releasing more. They start modulating these cells more. And so in doing so, we kind of experience an enhancement of empathy. And what I hypothesize, again, hypothesis, is that under normal conditions, serotonin release while experiencing empathy enhances the feeling you feel for someone. So I had that slide showing the various factors that modulate empathy, things like likeness and familiarity. I believe that serotonin is sort of encoding a signal for, I like this person, I care about this person. It's going to enhance the sense of empathy you feel through the modulation of these circuits. And so what I think is happening is that when you take MDMA, it drives serotonin release, and thereby sort of mimicking that phenomenon of, I care about this person. So that's it for my research, and now I want to talk about the third section of my talk, which is empathy in modern society. So some of you may have been still in the break, but I was introduced on stage with a video of me rapping. And that video came from TikTok. A couple of years ago, I got involved in social media by mistake, honestly. I posted a video intending it to be made just for friends and family, and it went viral, and I decided to just use it to educate the public. And so through, I've been very fortunate. So these are my followings on TikTok and Instagram, and she mentioned that she doesn't know what Bilibili is. I'm sure most people don't. It's basically Chinese YouTube. So I do have a channel in China. It's all in Chinese. I don't speak Chinese. I have a team that makes it captions. So yeah, don't worry if you don't know what Bilibili is. I didn't either. But through my videos, I just sort of try to educate the public as much as I can. Being a scientist, I feel it's my responsibility to help people understand. I'm of the belief that science has unnecessarily kind of moated itself with paywalls and jargon, and it's a bit frustrating. I think that there are many controversies that could have been avoided if there was greater public education. There's been a lot of talk about the SSRI paper. I think to most people, or the serotonin depression paper, I think to most people that came as a huge surprise. Low serotonin doesn't drive depression. Well, if you looked at the literature for the last 25 years, you would have found the same thing. There's no evidence. There's been evidence from years and years and years ago, but many of the studies that have tried to replicate that have failed. And so as a scientist, I was aware that the monoamine hypothesis was likely untrue, but when the meta-analysis came out and the news broke, it became this big controversy. And that was frustrating to watch because I thought, if any scientists had just come out and made this more explicit over the previous years, this wouldn't be such a controversy. You wouldn't have people dropping SSRIs immediately, which can have, lead to withdrawal effects. So there's a great importance for science communication, in my opinion. And so in my videos, I'll summarize recent papers. I'll talk about methods and experimental design and give some general lessons. As you can see here, sometimes I talk about psychedelics. It's great for public health messaging. When the suicide prevention hotline was changed in 1988, put out a video on that. It's good to just get the word out about things. And I do a lot of debunking misinformation and just sort of clarifying and setting expectations about science and specifically about psychedelic research. And nowadays, TikTok is sort of the great equalizer. It's allowed anybody with a phone to pick up, start filming themselves, and go viral. And there's no check for whether the information is accurate. The only check is really whether the information is compelling and whether watching it increases your heart rate. And a lot of the time, people will just post stuff because they've heard something about it. I really do think that a lot of it is unintentional. People will read something, they'll misunderstand it, they'll think, this is incredible, the world needs to know about this. They'll film a video, completely false, and it'll get 30 million views. And now you have 30 million people who have been fed information that's false. So I do my best to debunk these types of posts. And there's a lot of hype around psychedelic science and psychedelic medicine. And I think it's really important to adhere to the data and what we've seen. And I commend every single one of you for being here and for the conference organizers for bringing scientists here to talk about what the current state of the field is and how we next advance, how we do that cautiously, how we do that rigorously. And I think that's really important because you don't see that type of caution on social media. So congratulations and thank you to all of you. But you might be wondering why I'm talking about social media. Well, what I've observed and what has been observed by other people is that there's a lack of empathy on social media. In 2017, a survey was done, and at that time, this is in US adults, but 41% of people reported experiencing any level of harassment. And then broken down into other categories, terrible, 6% of people experience sexual harassment, 10% experience physical threats. This was in 2017, and I think we can all agree it's probably gotten worse. One more poll here. Raise your hand if you've ever gotten in a fight or been harassed or had anyone say anything mean to you on social media. Yeah, it looks like about 4 in 10, I would say. But the sad thing is that it's gotten worse. And that if you looked at the surveys from 2014, 2017, and 2020, the incidence of physical threats, stalking, harassment, sexual harassment, name-calling, and purposeful embarrassment have all increased. And as a neuroscientist and a person on social media, I ask myself all the time, why? What's going on? Why does this happen? And I think one big component is there's a lack of immediate repercussions, right? If you go up to someone in their face and you tell them, I think you're stupid, they could hit you. You could get hurt. On social media, that's not a possibility. No one can hurt you, and so I think there's a powerful sort of feeling there. The anonymity is, of course, powerful. It allows you to do things with no consequence. Again, many people just kind of scroll carelessly, thoughtlessly through social media. There might just be a level of, I'm going to comment this, and they don't even think about it. But the part that I think is the most interesting is that what we call social media is actually interaction without any social information. You're interacting with thousands of people. When I post a video, I could get 100,000 plays, and it's really hard to engage these empathy circuits of what is that person experiencing? Because really, users are not human beings. They're reduced to text and images. If you're fighting with someone, you're not face-to-face with them experiencing their emotional swings. You are arguing with a handle at whatever their name is. And I think that because of that natural empathy process where you immediately sense someone else's state is just blunted, right? That doesn't occur because you're not seeing someone. But what is possible is that cognitive empathy, and that you can ask yourself, how does this person feel? Is this comment that I'm going to leave going to hurt them? Is this going to hurt their feelings? I don't know anything about this person. They could be experiencing suicidality, and this could be the last straw for them. And I think that it's really important to be considerate of others in this way. It's easy to disregard the situations of others on social media when they don't feel like people. They feel like handles and images. But my supervisor, Rob Malenka, in this paper, he wrote, "The world's populations need more compassion and empathy for one another, and the study of MDMA provides one small but potentially important step toward reaching that goal." And I think it's important for us all to consider that by studying MDMA, we can understand the natural process that underlies empathy. And I want to add, the other night I was talking to the great Rick Doblin about my research, and he said, if the mice can do it, then so can we. And I couldn't agree more. So with that, I want to thank you. I want to thank all these amazing people, the Eden Foundation, for having me, and I would love to take any questions that you have about anything. And by the way, if you want to talk about social media or any of this stuff, I'll be around and love to talk about that stuff. So please find me. Right here.
Hi, thanks, and very interesting. I was just wondering, have you compared the surveys around the social media interactions and the responses with how, in real life?
Yes, yeah, great question. So, I did a survey once. I had the data in here, I took it out. I did a survey once on my TikTok. I asked my followers the same question, because I was curious, is this reproducible? And I found a little bit higher rate. Instead of 41%, I found like 48%. But then I asked them, how many of you have experienced bullying or harassing in real life? And the rate was something like 92%. So it is definitely much more prevalent in real life, unfortunately. I mean, this is data collected from TikTok. Many of these people are probably very young, but I'm sure most of us have also experienced harassment in real life, unfortunately. But I suppose the way I look at it is by the time you get to social media, you are probably an adult. You should be an adult, I think. And at that time, I think we can all kind of control ourselves a bit more. I think we all have experienced some bullying through early life, early childhood and school. But when it gets to adulthood, there's really no need to fight on social media. And that's what I see a lot is, people, I didn't mention this, but people will comment on my videos constantly. People will say, you're wrong, you're stupid. I hate science, I hate you. But people, and I just don't respond, it's fine. But people will comment and fight with each other. And I'll just get these notifications for days and days. People will just keep going back and forth fighting. And in my experience, I've not always been the one to say, oh, it doesn't bother me. In the beginning, I would say, screw you. I prepared this video. I know what I'm talking about. But for just advice for everyone, general advice that I share to everyone in the world, if someone says something mean, just completely ignore it. Because I promise you, if you respond and you start engaging in a fight, if you're at work, you're relaxing at home, you're with your kids, it doesn't matter. You're going to be perseverating and thinking, oh, I wonder if that person commented. I got to check. And you're going to keep checking your phone, and it just drains you. And so I think by neglecting it, ignoring it, you do yourself a service. And also, hopefully, by not giving them the satisfaction of a fight, you may be making them more likely to not do that to someone else in the future.
Hello, Ben. All the way up here, top row.
Yes.
Yes, I've been a big fan on social media and been following you for a while. This question also pertains to social media. I was curious, do you believe that you're one of a few, just a handful of scientists on social media. Do you believe that there should be more, specifically on TikTok?
Thank you, first off, for your support. I appreciate it. I believe that, yes, we need to have more scientists in general, a higher, more scientists per capita on social media, because I think, many scientists sort of look down upon it. They think, why in the world would I ever be on TikTok or social media? It's silly. But, what I tell those scientists is, regardless of what you think and regardless of how you act, there are always going to be billions of people on TikTok, and many of them are just going to be propagating misinformation every single day. And so, not that every scientist needs to get on social media and fight misinformation, but just having more people talking about, sharing their expertise. I mean, people are interested in hearing your expertise. People are interested in hearing, if you're a farmer in Iowa, people are interested in hearing what the life is like of a farmer in Iowa. And I think that scientists tend to be a little bit averse to the idea of being public-facing and putting themselves out there. But people are interested in hearing about what you study and how life is like as a scientist. So, and just by increasing the voices of scientists, I think that we can kind of even the playing field a little bit, perhaps. But I don't think that all scientists should be on social media. I think that would be a horrible disaster. So, and I think that everyone, if you're a scientist, you should try it. Give it a shot, film a couple of videos. You don't have to film it. You could post tweets, you could post audio, whatever is comfortable for you. And you might find that you have a natural knack for simplifying detailed concepts, or you might find that you hate it. And if you hate it, then there's no need to force it. But that's my opinion, and thank you for your question.
Hello, thanks for a great talk. I'm a somatic therapist, so when working with clients, I'll sort of often feel emotionally or even physically whatever kind of tension is going on. And I have no idea how that works neurologically. I'm not sure if anybody knows, but Can you provide some insight? What's going on?
Yeah, I mean, it's a great question. I don't think there are any studies showing that type of phenomenon specifically, but I mean, based on what I showed, there are data. So this whole idea of mimicking someone else's brain state, it's based on this theory called the perception action model, that when you see someone else experiencing something, your brain just generally models that. And it's been shown with like motor behavior. There are like mirror neurons that if you see someone moving their arm, there's mirror neurons that activate in the brain that will like signal the same thing if I'm moving my arm or they're moving their arm. And I think in general, probably the pain stuff does generalize. I mean, the other day, I was at home and my wife was like, oh, and I'm like, what's wrong? And she said, oh, I have a stomach ache. And like suddenly my stomach started to hurt and I'm like, is that what I'm studying? Is that it right there? And so I think it's possible. I mean, especially, if you're touching them and you're feeling the tension in their muscles, I think it's entirely possible that, you could be experiencing some representation, a mirror representation of that phenomenon. And personally, I mean, I think it's one of the coolest phenomenon that exists in science. I think it's pretty incredible that, two brains can kind of like share a space, a form of activity just by understanding what the other is experiencing. That to me is very kind of like outside of the typical bounds of physiological neuroscience, and so I think it's really fascinating.
Hi. My question is actually twofolded. The first one is, so when you isolated in the experiment and you took out the serotonin alone via the light process, and it showed the same results, has it not been the same experiment on the dopamine and the third aspect solely? So we see whether the dopamine also makes the same effect or whether it comes out differently?
We have not done that experiment yet, but it's absolutely important. Yeah, and I mean, is that what you're asking?
Yeah, that's the question, whether it's been done or not.
No, it has not been done. And yeah, it's definitely, so what has been done is that same study I showed where they put the MDMA into the nucleus accumbens and the mice became more social. They showed in that paper that dopamine does not have the same effect. So if you stimulate dopamine alone, it's very rewarding for the mice. And they will show like a conditioned place preference. So if they're hanging out over here and they're getting dopamine stimulation, and then they go over here and they're not getting any dopamine stimulation, afterwards they'll prefer to hang out over here. Or during, they'll also prefer to hang out where they're getting the dopamine stimulation. And so that whole paper kind of theorizes that the dopamine effect drives like the rewarding, pleasant experience of MDMA, and then the serotonin effect drives the pro-social component of MDMA. And so the lab is trying to tease that apart. But yeah, so we haven't tested that specifically in empathy, but it has been done in just general social interaction, and dopamine alone is not sufficient to enhance it.
All right, thank you. The second question was actually, regarding empathy. So empathy seems to be that some kind of a relation to the collective, or that you connect with another person via something that we don't understand fully. So the question is, it reminds me a little bit of the 100 monkey theory, that if you're aware of that one, that if you have 10,000 monkeys and they learn a new trait, if 100 of them learn the new trait, then all of them know it after a while. And that actually is a theory about agriculture and humanity. So the question is, what is your opinion of that? Is MDMA enhancing our understanding or connection to the collective?
Yeah, I think what you're describing is an evolutionary viewpoint on empathy, which is kind of what I mentioned at the beginning in that slide with the multiple bullet points, that empathy allows us to understand what someone else is thinking, what someone else is experiencing, and that's extremely valuable. And so as a social species, it's always valuable to have as much information about the other people as we can. And so I do think that empathy evolved naturally as a way to enhance social communication. And the way I view neuroscience and the brain is that we have all these systems that evolved naturally because we needed them, they were useful. Some of them are no longer useful, and some of them can be acted upon by substances like MDMA. And so I think MDMA is really just enhancing the activity of these natural systems that already exist upon us and that's why you experience so much empathy. I hope that answered your question.
Okay. Yeah. I'm here. Hello, here. Hi.
Hey there.
Hi, Ben. My question is a little more on the phenomenological or experiential level, because I noticed that you have this image of two heads with two brains, and the empathic bridge is going between the brains. But if you compare that to the images of, for example, the psychedelic artist Alex Gray, there's the whole bodies standing there. They are in a shared field of consciousness, and the connection is really going heart to heart. And when we, as therapists, experience what is popularly known as like a heart opening of MDMA, of course, the processes are probably going on in the brain, but people really experience at the chest level. Also, the first time I did MDMA, I really felt like a tickling in the nipples, and then this melting sensation in the middle of the chest. So I'm quite interested in what is actually what's actually going on here, because on the experiential level, there's sort of a softening in the breast or in the chest that seems to open up this empathic response, and probably why we talk to heart contact or something like that.
It's a fantastic question, and I will take the liberty to say I have absolutely no idea. These images I luckily found on Google, and I really like them. But as I demonstrated in the talk, it's not just about the brain, right? We're talking about experiencing pain, the somatic phenomenon, right? You're experiencing something throughout your body, so it's not just an emotion that you can experience, right? You all felt it. You see the person with the hands getting slammed in the door, sorry again, and you felt that discomfort in your body, Maybe it was just in your mind, but certainly it originates in the brain, in my opinion. Again, I'm biased, I'm a neuroscientist, but the phenomenon of what you're experiencing through your brain can certainly extend throughout the body into the chest, into the heart. And so it's an interesting question that, someone should study. I don't know if anyone has an answer to that.
Well, I could guess.
Yes.
You're not talking about oxytocin or prolactin at all, and I'm assuming that there's some place for that. And certainly, for upper-breast and nipples in women, men have nipples for some unknown reason, or maybe it's something there with oxytocin and prolactin.
Yeah, and for anyone who didn't hear, Julie Holland, who will be speaking later, she said that it could have something to do with oxytocin and prolactin. And I do want to say that we didn't test anything about oxytocin, so I showed the serotonin result. We haven't tested that, but I do certainly think that there could be a role for oxytocin in the phenomenon that we're observing.
I have a question. First, thank you very much for your presentation. And I couldn't help thinking about, I'm a psychologist, and I work with clients who are also neurodiverse and have different challenges in reading people socially. Could you maybe talk a little bit about the perspectives on this? I was thinking about, okay, can you use MDMA for microdosing with people on the spectra, or can you, if you have any knowledge on that topic, could you share some of your insights?
Yeah, so I showed in the beginning, I did my PhD research in autism. It's something I'm very interested in. And certainly empathy as one facet of social interaction is something that you would expect to be potentially altered in autism spectrum disorder. I didn't present the data here. Again, this is unpublished. There's a lot more to this study than what I showed here, but what I'm currently working on is exploring the same phenomenon in mouse models of autism. That is, mice that are carrying gene mutations that have been shown to induce autism or are associated with autism in human beings. And not to give away too much, but it appears that the mice show a deficit in this. They don't take on one another's pain as much. And not to go too far, once again, please don't repeat this because unpublished, but it does appear that MDMA is able to restore that behavior.
Yeah, so thank you. I'm a psychedelic integration coach. I work mainly with microdosing. And I just have this vision that one day I could bring MDMA to the Danish parliament and open the gates to the political hearts. So this is where I come from. I don't know if it will ever be possible. I have Maybe like Rick was presenting a heartbreaking case yesterday, and I heard it, this is the second time, I don't know if you remember the tombstone. This young Danish, I'm Danish, so maybe it appeals as the Jewish thing. I'm also Jewish, so I know what you're talking about. So he was talking about this Danish soldier that was going underground. He got an MDMA treatment. Somebody, obviously very empathic to his situation, helped him out. He saw a Danish psychologist, and she was denying him to enter the system, the structure, in order to give him his subsidies or his needed help, economic help. So I want to address this because it appeals very strongly, and it's not a social media issue. What I'm listening to here on the stage is a lot of structure, a lot of political fights, a lot of proof making, a lot of proof sensing. But where is the, like going back to Rick's case, where's the empathy in the research of psychedelics? And I know as a coach, I was trained in the US, we learned that it takes at least 60 to 90 days to bring a microdosing result in terms of whatever that result is supposed to be. I know my assistance is, as Rick was stating yesterday, damn needed. Not me as Anne, but me as someone who is mirroring and who has empathy in this process of microdosing. So I just wanted to bring empathy into, I don't know if you want to grab it or reflect a bit with me.
Yeah, I appreciate your comment, and I'm not even sure that I need to add anything. I think is well stated, well taken. I feel a lot of love and empathy in this room. I can tell that this is not a group that needs to be lectured on how to be more empathic or what empathy is. But you know, I think we all share a lot of empathy and compassion and interest and care for the psychedelic field. And you know, I think we all, in general, the world could use a lot more empathy right now. And that goes throughout research, throughout social media, throughout daily business life, whatever it is. Certainly no problem with adding more empathy into the world. So thank you for your comment. And I know I'm out of time, but I just want to say one other thing. I was expecting maybe to get a comment or a question about, you know, what about positive experience, right? I showed that MDMA can enhance this sort of negative empathy. It was a little bit, I didn't want to include it because it's very complicated to describe, but we did the same experiment where you have two mice that are both in pain, and one gets morphine, so they feel great. It's analgesia, right? They feel amazing. And you have another mouse interact with them, and you give that mouse MDMA, they will actually take on the analgesia. So they will actually take on the pain relief. So it goes in both directions. Not just that it's you can drive pain, but that you can also drive pain relief. So for anyone who might have been thinking it, I just wanted to throw it out there. But thank you so much again for all your great questions and for having me. I really appreciate everything.